Well, let us take a clear look at the question. Let's read the question in detail. Then we go for solving this. You can refer back to the image of this question even later on by getting back to these images. Now see, consider three sets E1, F1, G1. Two elements are chosen at random without replacement from the set of E1. Let S1 denote these chosen elements and then E2 is equal to E1 minus S1, E1 minus S1. F2 is equal to F1 union S1. Now two elements are chosen at random without replacement from the set of F2 to form the set S2. Let G2 is equal to G1 union S2. It's a long and complicated question, remember. Finally, two elements are chosen at random without replacement from the set of G2. Let S3 denote the set of these chosen elements and E3 is E2 union S3. Under the given condition that E1 equal to E3, find the probability P that the event S1 is 1, 2, this event S1 is 1, 2 and then find the value of P. Well friends, we can begin the question here. This just reading the question took us more than 1 minute. This is usually true in case of an advanced question, especially when it is a very subjective and long question. I will just make space here for solving this question just as is given. We will read the question line by line and then form the calculation. Let's go ahead now. See, the question says that there are three sets. E1 is carrying 1, 2 and 3. E1 has 1, 2 and 3 as elements. F1 has 1, 3 and 4. And G1 has 2, 3, 4, 5. 2, 3, 4, 5. Two elements are chosen at random without replacement from the set of E1. Let S1 represent these chosen elements. Two elements are chosen at random from E1. That means we can begin the question from this step. How many S1 sets can be made? Two elements taken, it can be 1, 2. It can be 2, 3. This can be 1, 3. Two elements are chosen at random without replacement from the set of E1. Let S1 denote the set of these chosen elements. Now let E2 is E1 minus S1. Next step, E2 is E1 minus S1. So let us form E2. This is E1 minus S1. This is E1 minus S1. We have a 3 over here. Here the E2 set would be equal to E1 minus S1, means this E2 would be equal to E1 minus S1, means only 2. Next, F2 is F1 union S1. F2 is defined as F1 union S1. Let's say we define F1 union S1 is your F2. Now this is F1 and this is S1. That means we have 1, 2, 3 and 4. F1 union S1. Now next, F2 for this case is F1 union S1, means again 1, 2, 3 and 4. Again F2 for this case is F1 union S1, that means 1, 3 and 4. This is the case of F2. Now without to form the set of F2, F2 has been formed, and let S2 denote the set of these chosen elements. Now two elements are chosen at random without replacement from the set of F2. S2 denotes this set of elements. Now how can you form S2 over here? Now see this. S2 formation in this case can be 1, 2, 1, 3, 1, 4, 1 to 2 comma 3, 2 comma 4, and lastly 3 comma 4. Pairing of two elements taken at a time. Now again S2 in this case is equal to same as in here, 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, and 3 comma 4. In the last case, the set of S2s will be only 3 sets, that is 1 comma 3, 1 comma 4, and 3 comma 4. Let G2 is equal to G1 union S2. Now G2 is equal to G1 union S2. G1 union S2. This is your G1. This is your S2. Now in this case, this G1 union S2 can form how many cases of G2? G1 has 2, 3, 4, 5, and here S2 has 1, 2. That means the sets which carry 1, 1 and 1 can form a possible set as 1, 2, 3, 4 and 5. Observe G1 union S2. 1, 1 and 1 will be, you can say, unioned or added with the elements of 2, 3, 4, 5, creating this. The other three, these three do not have any 1 and they carry all the subsets, all the possible subsets of G1, and that means you can form or 2, 3, 4 and 5 as a possible union set here, G2. This is the possible case in this case. Now here also the same allocation will be valid. That means here the G2 again shall be either this or this, 1, 2, 3, 4, 5, or it will be 2, 3, 4, 5 simply. Whereas in case of this, the G2, the possible evaluation for G2 can be like, if I take these two sets with G1 union S2, then I can have 1, 2, 3, 4 and 5. Whereas with 3 and 4, it can be simply remaining as the set of G1, that is 2, 3, 4 and 5. Let me make a noting for you that this one and this one form this set. Again this one and this one form this set. Again this one and this one form this set, and like this. In the next step, two elements are chosen at random without replacement from G2, and let S3 denote the set of these elements such that E3 is a union of E2 union S3. Now S3 calculations can have several possibilities, but the end result should be such that E3 should be equal to E2 union S3. Now see this. The end result E3 should be equal to E2 union S3. And S3s will be formed after this. But this is finally supposed to be equal to E1. And if this is supposed to be equal to E1, and that means I should have end results as 1, 2, 3. This is what should happen after taking a union with S3. Whereas E2 is simply, your E2 is simply, where is your E2? E2 is only 3 in this case, only 1 in this case, and only 2 in this case. Now if I want to form 1, 2, 3 as a union set, that means along with 3 I should have 1, 2, and which should be provided by S3. S3 should provide 1, 2, and which is possible. That means from here, if the S3 carries 1, 2, then on union with E2 I can get 1 comma 2 comma 3. This is one possibility out of how many? Out of 5 C2. This is out of 5 C2 equal to 10 possibilities. This is out of 10 one possibility out of 10. Now again, any other possibility here would not be useful, because I would require along with 3 simply 1 comma 2, and that is only once possible out of these 10 possibilities. Again, from here I would not really get anything. There is no possibility here to create 1 comma 2 comma 3, because there would not be 1 in any of the sets. Now from this again, the same case as this, if I take 1 comma 2 as S3, then I will get with union, just a moment, now I made a mistake. S3 should have 1 comma 2 comma 3, that means this should have 2 comma 3. This should have 2 comma 3 in element. So E2 union S3, E2 union S3 would produce 1 comma 2 comma 3. Any other possibility would not be useful. Now simply one from here as well, 2 comma 3 here as well, I can have an S3 as equal to 2 comma 3. With E2 having 1, then I can form 1 comma 2 comma 3. And from here I can have an S3 as equal to how much? If E2 is 1, then I can have 1 comma 3 from here and create 1 comma 2 comma 3, and from 2 comma 3 and 2, no, 1 would be missing from here, I would not get anything. So 0 from here, nothing from here means let's put a cross, nothing from here means let's put a cross. This clubbing with, oh so sorry, this is not crossed. This belongs to this 2 comma 3, here the S3 2 comma 3 belongs to this, and well, E2 is here, so 1 comma 3, S3 would be 1 comma 3, this S3 belongs to this one, this S3 is equal to 1 comma 3. Excellent. 1 2 3 1 2 3 1 2 3 and then 1 2 3, and that's all. That means I do not have anything here, and then I do not have anything here, that is all. If this is how the branching of the calculation comes, then if we go for calculating the probability P, which is a conditional probability, given that E1 equal to E3 has occurred, given this has occurred, then what is the probability that the S1 set will be 1 comma 2? That means this is the event whose probability is equal to P. Probability of this event should be equal to P. Now if we go for calculating that, let's have a clear look at this question back again. This E1 is trifurcating into 3 equally probable events. That means 1/3 is the probability of each, but we need not take care of that. Why? Now you look at the resultant. This particular situation is what? Is the given event. This is given event. That means this is the primary event or priori event. Now, how is this situation coming into existence? Look at this. This is a formation by a probability of 1 by 10. 1 by 10, but this is forming from this, and this is formed from which things? This is formed from S2s, and S2s can be creating this particular G2 with a probability of 3 by 6. 1, 2, 3. These 3 things create this thing. That means there is a probability of half over here. So how we go for calculation is something like this. Say for example, we make some space right here. Let's say we make some space over here. Let us begin with this branch calculation of probability. This S3 will be possible 1 by 10 times formed from this, and this will be formed 3 by 6 times, that is half. Probability of S2 here is half, forming this, and S2 is formed once from here, and one's from here and one third from here. So that's all about the calculation of this, and this is the event which is your favorable event. This is the only event which is favorable, because you require this to be the event of whose probability you need to find, and this is 1 comma 2 as S1. So when S1 has elements as 1 comma 2, this is how your E3 comes up as equal to E1. This is how E3 comes up as equal to E1, and that is possible only through this particular thing. So this is your favorable part of the calculation, or this is the favorable outcome or event, and hence this will remain in the numerator, whereas denominator also will carry this. Or other possibilities of forming E3 equal to E1 is through this, which is 0. Through this, let's come to this. This is formed out of this, again 1 out of 10, that is has a probability of 1 by 10. But this is itself getting formed 3 by 6 times, that is half. And that's all, remaining things are formed only once. And next, this is done. Now this one is formed from this, and how much is this probable? What is the probability of this? Probability of this is, let's say, 1 by 4 C2, probable 1 out of 4 C2, that is 1 by 6 times. So 1 by 6, this is formed 1 by 6 times. 1 by 6 times this is formed out of these sets of S2s, and hence you can say this has another half with it. And what else? These are ones plus this one has what probability? 1 by 10, and therefore another 1 by 10 dot 1 by 10. But this is formed from these sets 2 by 3 times. Out of 3, only 2 are favoring the formation of this G2, and hence 2 by 3 times. And remaining probability goes to 1. I mean, goes to 1 means these are 1/3, 1/3, and 1/3. They are equally probable, and that means whenever you will use these 1/3s, they will get eventually cancelled, both above and below in the denominators. And how many possibilities did happen? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5, and this is 0. Done. Let's complete. Let's complete the calculation. If we go for calculating this, this is like 1 by 20. So I will take the 1 above and bring 20 below, bringing 1 here, bringing another 1 here, and let's say 20 by 12. Let's write down here 20 by 12 plus 40 by 30, means 4 by 3. Let's say into 4 into 4. So how much does that make? This is 12, 16, 36. Just a moment. 1 by 10 into half, 1 by 10 into half, 1 by 6 into half, 1 by 10 into 2/3. Oh yes, there is something amiss in the calculations. 1 plus 1, 1 by 12, 20 by 12, and then 40 by 30, 4 by 3. So 16, 16 plus 20, 36, 36 by 12. So 36 by 12. 36 by 12. Yeah, that is right. 16 plus 20, 36. 36 by 12. That makes 3. Oh yes, plus 3. And that means the answer is 1 by 5. Absolutely correct. This is the answer here. And now you see how long this calculation goes. By explaining, it took a little more time. I hope you can go by direct approach of calculation without any wastage of time, and still it can take a little more than 5 minutes. This is how big an advanced question can be. Anyhow, let's see in the next question. Thanks for your patience.